Trần Hoàng Anh 2021-2355. So today I will do an exercise. I will do exercise on the training resources. The model corrections or detections. So here we use rapid miner to inspect correct correlation between our attribute. To follow along, you will need to accept to the floor and detect correction matrix process. So after I taking example, so I will press the run in here, and you can see that nó chạy nó lâu. The data đâu? Đúng mà. Correlation matrix. Yes, here. So we can see that about the statistics, we can see that all the attribute is type polynomial and some of that is integer in here. So now I will use corrections matrix here and press the run, and you can see that it's an Caesar. Oh, all the attribute result here. Okay, cái bảng nó nhiều. Oh, have to run correlation matrix in the object view and to attribute numeric. So after it, we can see hình như mình thiếu cái gì đó rồi. So inspect numeric attribute correlated with correlation matrix. So after I add it to here, I also took it here and press the run. So the correlation matrix, before I choosing the numeric, you can see the current matrix are very, the value only appears at here. So we can sort by phone durations and number of exit credits, and the last will be the end up with the zero is the late wicket streak, and the number of exit credits has the strongest exit number is 1 equal to 1. This is based on its linear independence from those others attribute because credit amount is 0. Credit amount is 0 in here. It's probably strong corrected to other attribute and could provide redundant information. So look at back to the matrix, and here's there are a lot of missing values for all of those nominal attributes. Then in the lower right, here we can see the integer attribute, and here is the credit amount. Credit amount. Yes, credit amount. And we can see that it's highly corrected with both duration and credit month. Credit month. So in here, I will change the attribute filter by change from the numeric attribute And you can see that uh, the matrix here, the all missing value has disappears. Then square. Oh, I need to type square. Oh, okay. So as I already told, we can clean up the matrix and all the vary between 0 and 1. So that is so correction clean this one. Mastering manipulation.
It might also be helpful to have access to the XMeans clustering process. To begin, let's go ahead, run the process, and look at our data. You don't need to worry about the label right now. We're not using it. The rest of our attributes all look numeric. We can take a quick look at statistics and verify that all of the other attributes are real. Back to design view, we want to use the k-means operator. We can find that under modeling and segmentation. I will select k-means and press enter to add it to the process. Make sure it's connected up correctly. For now, keep all of the default parameters, but let's go ahead and also get clusters set up, then run. Here we have the cluster set. That is the data with each of the clusters labeled. In statistics, we can see the role of that attribute is clustering. Then over to the cluster model. We have several ways to view the cluster. Description provides accounts of items in each cluster. The folder view contains each of the individual records by cluster. The graph shows that same information that's in description in a visual format. That is, the size of the circle indicates the size of the cluster. Centroid table gives us the specific attribute values by cluster for each of their centroids. The plot shows us the same information as the centroid table in a visual manner, where each line or color represents brackets, our values. For the measure types, let's change this to numerical measures, and then for the numerical measure, we choose Euclidean distance. Let's leave the other parameters where they're at, and then find the cluster model visualizer. Again, if you search for cluster, you can find it under modeling and segmentation. Make sure it's wired up correctly, and run. Now the overview provides a lot more information. Again, this is the output of the cluster model visualizer. It tells us how many observations are in each cluster and provides an easily interpretable explanation of some of the most significant attributes for that cluster. The heat map gives us information, again, about the centroids for each cluster and their attributes. So we can see, for example, that for cluster 2, foreign worker equals unknown is displayed in a different visualization type. And we can see that same spike here. And then in the centroid, one point in cluster 2. Operator, that was easy. Take a quick look at the clustering and open up a fresh process. Here we have a clustering process based on k-means, and our task is to choose. So, choose and use. 60 is parameters, means, and our task is to change it to X means. So right click, replace operator, modeling, segmentation, and X means. Now it's an X means operator. That was easy. Take a quick look at the parameters. It already has numerical measures and Euclidean distance. But let's change the range of K. 60 is too many. Let's bring that down to 20 so that it will look at possible values for K between 3 and 20. Notice we have the two options between K-means and fast K-means, and the other parameters look familiar. Then run. Here's the model output, and here's the cluster model visualizer. It looks like it's settled on 3 clusters. Cluster 0 has almost all records. And then we have 2 very small and focused clusters. Then we can inspect centroids through these different methods, the heat map, the centroid chart, and the table, and take a look at the scatter plot. So that's how to implement K-means and X-means cluster.
What's all? So in here's, oh my God. So here I will do the credit risk case means clusterings. Then you can see here I already open it. So before that I will make a run here. There are nothing. We can see all the types of attribute. Here's all the real. And that to follow what I will need a credit risk claiming clustering process. So I will adding a implement k means k means to here, and I will change the k to the 7, and the measurement is numerical, and number of measure will be Euclidean distance, and I will change this max run. Probably I would change to 30, I think. Oh no, yes, max runs. And inspects including matrix parent custom graphs. So looking at we can use the cluster model, sum the cluster from 1 to 6. There with the number of items. The folder view, we can see each of the item inside the clusters and the graphs of the item of the cluster from 0 to 6. And we can see the plot in here. We can find it under modeling segmentation. I will what should I say? We can see that the attribute is here is the clusters. Oh, I think uh, we can see the result here. Before that, what do I, oh, visual histories. Nó bị mất một cái folder của mình. Okay, we can see the result in here. The table is given a specific attribute valued by clusters and each of their centroid. The plot is show us the same information as the centroid table and a visual manner where each line or color present one center. For example, here's on there or on the red line, you can see the red line here. A red line. Often you cannot see. You can here. You can see that at the housings, I guess. A high value for the attribute and other deep toy equal to co-applicant back to the centroid table. Centroid table. We can find the cluster 4 in here and other deep depths equal to co-applicant is 4.6. 4.6. Back to the design views. Now let's change some of these parameters. We can bump up 5 to 7 as I already did it. Oh yeah, bring it all and leave the max will be 10 and determine a good start variable for measuring time. And we can see that it is changed differently. And it had been changed already. Cluster expects. Okay, then I will stop the clustering in here. So next to the example, I will do it the credit risk X means clusterings. So in here, I will change this to maybe I will change the k-mean the 2 and the mark is 20. And I will inspect the various output. You can see that in this, I also change the clustering, replacing by using the modeling segmentation and the X mean here. Here is 2 and 60 is too much, so I change to the 20. I also take it as a numerical and Euclidean distance. So in here, you can see that the cluster model here only have 2 clusters. And the class is also have only 1 and 0 items. The plot, and you can see the plot in here. And let's now the overview provide a lot of information. Again, this is an output of cluster model visualizers. It tells us how many observations are in each clusters. Yes, in here, and provide an easy interpretable explanation of some of most significant attribute for that. Uh, attribute for that. Cluster the heat map. Give us informations. Map. Here's informations against about the centroid for each cluster and the attribute. Here's and so we can see, for example, for the cluster 2, we can see for the cluster 2, domestic, for the cluster 2, maybe yes, foreign worker equals unknown has a high value here, here's the highest values. highest value, foreign worker, foreign unemployed, gender, foreign worker, all applicants, all others, unemployed, all applicants. Oh, foreign, yeah, foreign workers in here is the highest. We can see the same informations in visualization type, and that is all. So I think so. Now I comes to the example about the FP growth. So after clicking to the transaction FP grow, I will inspect each in three ways. The same data has been prepared.
To follow along,
So for each, okay. So first I will go to the generate, uh, and add an in break in the generate section, break in here, and I press the run. So you can see here, and for every item in each stack, there only one row, and continue. Now the data has been prepared in a three-way. We don't have to do all of this. Oh yeah. Okay. Yeah, in a three-way, we won't have to do all of this. So with after that, take a look at this three. We got some Akin dumping coding possible item, and there will be one attribute. And then it is true that attribute is in the basket, and for if the item is not in the basket, one row per basket, and there has been an advantage of it a solid logical structures, but it can grow excessively large. The next is one trims it down instead of an attribute for the max item in the baskets. Basket here. And this compress the data, but it has been the disadvantages that the structure isn't quite as illogical. If we look at the meaning of the basket, it can be a little bit difficult, but it's not the same from the one basket to another. Go to the one column. It has a similar in it also. Yeah, create some text characters like the pi or the separators. It has been the advantage of is very clear and what the ID is and very clear the item attributes. However, within the items, it could be difficult to spot errors because its separation are only based on text. And let's go back to this. And I will add the FP row to here and bring the next one to here and the next one to here. And that after that I will change that in okay. And here's and here. Okay. And now for the first one, the item on the one column, that's the last one we look at. So we can see it in here. We change the item to the list column. As this is separated in here. Oh, here support 0.5. And the second one is oh, item. This column is also And the dummy cost is to the list of column. Ờ, and cái hai là in separates. Và thứ ba and the last is the dummy. Okay, so I will pass around in here. And we can see that, look at this, we should see all the data. Uh, the data in here, also the formal. The next one, we go to transactions and we scroll, apply both ethical and association analysis. In the different example sets. Okay, I didn't get it that much. So after it, I will do the hotel app associations. Before I will add a big point here and also in here. And discrete title growth and I press to run. Oh, it took so long. Nó phải lâu dữ vậy bay. Ừ. Okay. We can hear the table. We can have the table. We should see the similar to the baskets. And the same data we have seen before to try to pick the tune, but looking at the association, can still yell is uh, range, digitize them. I can see a lot of information in here. You can see the age at here. Each value has been previewed out and multiples of those. So we come and we will add FP rows to this. And yes, and we remove all the breakpoints, runs, and see support so the scale frequency of the single item or the set of item here and get a little bit interesting to look at too. An item set have the strongest supports. And if we follow the list down, we can into larger and larger items. Go back to design to the F we grow. We change this to the minimum by 60 by 0.6 and go to the min number of the item sets to at least 100 item set. Even if it is can find 100, that means the minimum support. There's the minimum support. So we want to either decrease. So So I should change this the number of items set like more than like this. Oh, the maximum is smaller than minimum. Okay, got it. This may is two. I will let it 100. 15. Yes, yes, yes. I correct. Okay, okay. Also, oh my God. Create association. Association. I will create association rules to this. Oh my God. Why no? Yes, maybe here it here is correct. Okay, the I would change this to 0.6 and that's all with confidence. Better runs. Stories. So details. Close. Oh, okay, it cannot see. So since I cannot see right now, oh, there are mistakes during my app. So I only did this.